Hey, welcome back to Math with Patrick. Today is November 21st. We do have Quill with us today, and we're solving problem 325 from the Daily Epsilon calendar. And we should show why the answer today should be 21, because that matches today's date. So we have 4 students, and it takes them 3 hours to solve 20 problems. And if we're assuming that we have the same rate of problem solving, we need to figure out how many hours it'll take 3 students to solve 105 problems. Okay, so just like kind of some number sense, it looks like we have fewer students, so it should take longer. And we also have way more problems, so it should take way more longer than just 3 hours. So far it does make sense to me why the answer would be around 21, just because that is pretty big compared to just 3. And I think here we should just set up a proportion where I'm thinking it would make the most sense to me to put problems on like the top of my fraction, and then both my students number and my hours number on the bottom. And I'll explain why in a sec. So I could put 4 students and 3 hours here. And essentially what I'm trying to do is I'm trying to find some rate of problems per hour, but also problems per student. Because you can imagine if I have more students, then I will probably be able to solve more problems and maybe within the same amount of time. So I'm thinking like I could kind of proportionately increase or decrease the numerator and the denominator by the same number, and it would still make sense. Like if I say doubled the amount of students I had, still within the same time frame, I would be able to now solve double the amount of problems. So this proportion here, this fraction, is still equal to the other one, and basically I'm just trying to, increase or decrease these numbers by the same factor, but not both of these at the same time, right? I could also maybe think, okay, I still have 4 students, but then I give them double the amount of time, and assuming they don't get tired after a while, they should also probably still be able to solve the same number of problems. And then if we compare like these ones numerically, we just get 40 over 24 for both of them. This fraction over here that we began with is 20 over 12, and still we are keeping the proportions the same. So anyways, let's actually try solving the problem by inserting some of the numbers from down here. Looks like we only have 3 students now. We don't know how many hours it's going to take, so I'll just do X hours. And then now we have 105 problems up top. And again, I'm trying to just figure out how to make this fraction equal to this one. I think the easiest thing would be to, at least for me, is to create some kind of unit rate here. Like maybe instead of thinking about it as 4 students right now, I could just bring it back down to 1. Again, assuming that all students are working at the same rate, I'm allowed to do this. So I'm just doing 20 divided by 4. That's going to be the same thing as just 5. And so one student can solve 5 problems in 3 hours. Now I do have 3 students in this fraction, so then I'm going to change it again, where I'll go times 3 on top, and then times 3 on bottom. And then now I've at least matched the amount of students I have. And all I'm really left with is wondering if I can get this 15 to match this 105. And I think I can. I think I can just do times 7. And just to show it, 5 times 7 is 35. 7 times 1, or technically 7 times 10, would be 70. Adding those together is 105. So I am allowed to multiply by 7 to go from 15 to 105. So to keep the proportion the same, I should also multiply my time number by 7. And again, as we saw in previous examples, it does make sense to keep the number of students the same. I don't also need to multiply that by 7. So seeing that we had 3 hours over here and X hours here, well, 3 times 7 tells us that X is 21. And that is how long it's going to take 3 students to solve 105 problems at that same rate from before. So we're all done. That's the whole problem. Hope you enjoyed. I'll see you tomorrow. Bye.